Hi, everybody. That was a great joke from my boss, Mike, to send me here. First of all, I barely can speak English. Second, I am not a data engineer. And the third moment, I don't like meetups, but probably this one will be interesting. So, a few words about me. I'm from another culture. 12 years I was a C# developer in Russia, and last few years I'm doing Python development in different forms of it. At this moment I'm working with Vigilant and going to work more. So, and we are doing a pretty nice and interesting stuff that I'm going to talk today. I definitely sorry for my mistakes during this presentation, so hopefully everything would be understandable. So, what about Vigilant? At this moment, Vigilant aggregates a lot of public open data and provides the single access layer in two ways. In human-readable way, when we provide the search platform, and in machine-readable way, when we provide a pretty nice rich API. Plus, we have a bunch of interesting features for people who want to know about information earlier. So we are doing a real-time monitoring and real-time notification. So exactly in the moment when we scraped something interesting, we can deliver it to our client via different real-time and non-real-time channels, from email to Slack and so on. So sometimes we are doing custom solutions on top of data that we are scraping. Plus we are doing a bunch of internal mesh apps that provides like a different additional functional to particular like spheres of data. Yep. So let's speak about our stack, and this stack probably will be very familiar to all of you. I'm pretty sure all of you knows these icons. Yes, this is unknown Chinese key value storage, and we are using it in production. We will talk about it later. It has no logo, it has nothing, even documentation in Chinese, but just believe me, this is the perfect product. So, how this stack works? 99.9% of our infrastructure written in Python, and somebody can say, come on guys, Python is good probably for data processing, but what about everything else? No, we are doing everything in Python, and we will speak about it a bit later. We are trying to squeeze out maximum performance that probably Python can't do at all. We using salary. Salary is gross, but it's still the best way to distribute workers across the network and to distribute tasks across the network. As main message bus for salary, we are using RabbitMQ, and as main message bus between our microservices, we are using NSQ. If nobody tried NSQ before, I definitely would recommend it. It's similar to Nets, and it's much better for us than Kafka, for example. So you definitely can guarantee the delivery of package. You have different exchanges and so on, and it's unbelievable. So we are using Elasticsearch. Elasticsearch is a cold storage in our situation. So imagine that we have Python workers, they are scraping the internet, they are getting a lot of data in different formats, and they first of all pushing it to Elasticsearch. So the cold storage is Elasticsearch. The hot storage is Postgres, and there we're storing the snapshot of data. So user always can go back and to see what was results on the period of time when he did this search, right? So if we're talking about our deployment pipeline, it's a self-hosted GitLab, and I would definitely recommend it. It probably was the best experience I ever experienced. Everything wrapped into Docker containers and deployed into Kubernetes cluster with Rancher. And definitely this pretty nice Chinese key value storage. We'll talk about a bit later. So what about problems? Today we will speak about our problem that we almost solved, and we are in process. We have a huge amount of different sources. So at this moment it's more than 1.5 thousand, and it's absolutely different sources. And new sources being written every day, old sources can be broken every day because everything is changed. Different changes in API. Sometimes it can be web scrapers. I'm pretty sure all data engineers here know how this zoo looks and how difficult to keep it running forward, right? So regular bands, connectivity problems, scraping protection system, and all this stuff you need to control, and all this stuff you need to bypass. And this is a question of performance too, right? Plus data quality. So you cannot provide and disinform your clients even if something happens during delivery, right? Plus multiple source devs and contractors, it's messy too. So you can have a bunch of new sources from different people, and you need to control this somehow. Plus, specific source nuances multiply these problems. When I'm talking about specific source problem nuances, let's imagine the situation that some courts in New Jersey, as I remember, works from 9 a.m. till 6 p.m. After 6 p.m., the source doesn't work. Or for example, you have a source when you need to log in to input your email, then to wait an email with link to download a PDF file with scanned images that you need to OCR and extract data from there, right? Whew. So, how it was before and how we solving it right now. Before it was pretty monolithic. It was a mono-repository when we have a bunch of scraping scripts. So each source is like a standalone scraping script that have an input, some query, and output. Because we are doing not only periodic searches, we are doing live searches too. So in real time, you need to go to some site to extract data from there, to pipeline through post-processors and pre-processors to extract the meaningful data and to provide it to the user, right? So first of all, we break this monolith, and we had a mono repository. And we're still keeping this mono repository because it's a pretty nice self-describing knowledge base. So all source developers can literally see other sources and can quickly modify, for example, a bunch of them, or can quickly check if they are doing right or not. So yes, the documentation definitely solved this problem, but when you have the access to everything at once, it's much better when we're talking about different batch tasks. And we get rid of Git-based phase of deployment the next way. So it was a decision to wrap absolutely each source to individual Python package. So you contribute in your amazing commit that, for example, fixes some code, and now it delivers. Everything is going to GitLab mono repository with all sources. Then GitLab pipeline starts, and in-house made utility doing a bunch of stuff here. So first of all, it detects which sources were definitely changed. Then it versioning them, doing static tests, doing basic tests like checking for imports, building a package and pushing into self-hosted PyP repository. And here's the moment. So if something is going wrong with your commit, you definitely don't have a message about this in your Slack private channel. So you always can understand what exactly is going on, and you directly from here can deploy it and so on. So it's like a repository within the repository. Yes, we're using PEP 440 for versioning. It's a pretty nice stuff because in each version you already have a commit that exactly affects this version. So you always can understand what exactly happened, go to this commit and understand why this regression happened and so on. Let's speak about our proxy layer. So that was a solution to avoid different problems. First of all, we have our own IP pool with Crank. Crank is the name of the proxy. We have our own IP pool of Crank nodes. So we proxy absolutely all requests through this distribution level. It allows us to do few moments. First one, we can masquerade it on the fly. So we change in headers, we change in user agents, and you don't need to do it on the client side, right? Because everything is going through this layer. It's man in the middle, so it's not a problem to unwrap HTTPS and to replace headers and to push back. Yes, we are doing HTTPS to HTTP degradation when requests are going through this layer, because as you know, HTTPS takes more time just because of handshaking. Right? So, plus a bunch of rule sets. In modern world, it's difficult to imagine how you can scrape some source only with, for example, Python requests. So you definitely will use headless browser, for example, right? And it's very difficult to ask headless browser not to download a different type of extra context, like CSS, for example, right? So we are using a bunch of rule sets to drop this stuff. And we have a centralized cache for absolutely all nodes. that caching all content that we grabbing from the internet and reducing the pressure for third-party sites. And that's how this Chinese key value proxy, key value storage helps us a lot. Imagine the situation that nobody knows, but somewhere in China, there is a wonderful product that in production in at least 4 or 5 gaming platforms with hundreds of millions of users. And it works blazing fast. It had before LevelDB as a backend. So imagine that it's LevelDB, plus you have a very fast HTTP server on top of it. So nice, right? Plus Broadly. Broadly definitely helps us a lot. Broadly, it's a Google algorithm to compress data, and it works very nice with HTML content. So we're storing less, caching almost everything, and doing it in a very nice way. What about performance? The funniest moment that this proxy server was written in Python. And this is a question like, guys, why not Go? And many Python developers today are looking at least to Go, like, oh, Go, nice. Even Google tried to write a Grumpy, right, a transpiler from Python to Go. It wasn't finished, but anyway. So I can say that today in 2018, it's absolutely possible to squeeze out everything from Python. And it's definitely async IO. And it's definitely UV loop that allows you to use libevent library and make it even faster. And it's a bunch of products that built on top of async IO. Plus, we using typings. I'm pretty sure all Python developers knows what the heck is this. Just because we almost sure that in a few next years everything will change and we will have a bunch of different optimizations, transpilers and so on that allows you to make your Python code much faster if you're using typings. What about Elasticsearch? This is an interesting moment too. So we were forced to create a few additional moments to Elasticsearch. The first one, we injecting the high-level schema to each Elasticsearch index. It allows us to not to use the Elasticsearch types on the lowest level. It allows us to have the real picture, the real schema of what data do we have in Elasticsearch. And this step allows us to do a different migrations. So yes, it's possible to reindex one Elasticsearch index to another using some scripts, for example, in Groovy or Painless. But you have no power of, for example, you have no access to your infrastructure. You have no power of Python ecosystem and so on. So when each index contains the high-level schema, it's not a problem to build a tool that allows you to convert data from one schema to another. And you can keep your old data without sometimes I forget English words. So that's how we pushing data from one index to another. And as you can mention, we have a git commit in the index name, so we always can understand who exactly produced this data. And if something is wrong with this data, we can go back, check, and understand what's going on here. So what about tests? The biggest problem here is to provide a real qualified data to customers. There is no other way when you can disinform them. That's why you need to build a bunch of different tests. So we have two huge testing services. The first one, testing source itself. We are going to our Elasticsearch warehouse. We are doing probe, so we're taking some record from there. Then we are using this record to repeat the search with existing source script. And if after the search we have the same record, we already can say that probably everything is fine. And when you're doing a bunch of iterations with random probes from your store, you definitely can check that script logic itself works fine. And if something changed, probably somewhere something is broken. And the second moment is data testing service. So before we're going to release any Elasticsearch index to the public, first of all, it's going to be a candidate. So against the candidate, we can do a bunch of tests. First of all, we can compare it with previous version and to see any kind of degradation here. Second one, we can test data itself. So a bunch of different checks that allows you to understand. So for example, in schema, this column is a date. And then we are going to try to check that all dates are here and what is the percentage and what's going on here. Any kind of deviations and so on, red flag, select notification, and we are going back. So this is how we were able to reduce the mess here. And this is how we were able to have a bunch of different developers from different countries to work on the same product and to add new sources every day. Hope it will be useful and interesting for you. Yeah. Thank you, guys. And we are hiring.
Anybody has questions? If you could just wait for the microphone because we're recording.
So can you give us a sense of what kind of data you're collecting? You mentioned like 1,500 sources, but what kind of data is it? Is it like weather data real time from NASA or?
Okay,
Yeah, who's using it?
I got the question. So, for example, we have almost all courts from United States. So we have information from them. We have different data related to finance and political stuff. For example, we have all political contributions and so on. So it totally depends on which focus do we have and which clients do we have now. But if we're talking about the kind of data, it's absolutely different types. So it can be from scanned PDFs to Microsoft database access or some binary old style Excel documents, right? But if we're talking about like where is this data coming from, it's usually public data, it's usually open data, and usually related to finance and political stuff. And not only. So it's not a problem to check some background here without any kind of problems. You can find any violations and so on. Yeah. I'm sorry that I didn't mention about.
No?
Come on, guys.
Oh, okay. Well, oh.
Was this the... Is this working? Was this the first iteration of your whole stack? Like, did you build it this way from the beginning?
That's a good question. No. So if we will go back to the beginning and check stack itself, we definitely didn't use NSQ. We used Celery much more, but it's very similar to initial stack. So if we are talking about deployment pipeline and so on, it's a fresh stuff. Do you like our stack? Yeah, awesome.
Dealing with those many data sources, how do you deal with different versions of the data being, replaced?
That's a very good question. So every time, when we're doing live search, all live searches, real-time searches, are going to the same index. If we are doing periodic search, absolutely all periodic searches are going to separate indices. So when we are talking about periodic, it means so we're scraping absolutely everything from some source, and there is no reason to overlay it. We just creating a snapshots of them to be able to compare them and to be able to understand if something has happened there. Somebody making photo, I need to switch. I'm kidding. Yeah, I hope I answered.
Hey, a question about the type of data. Is it mostly like transactional type data, or do you have any like event data type, like serious?
Okay, so about transactions, not always. A lot of transactions, definitely. You asked about time series? No, definitely not time series. Maybe transaction plus a bunch of like attributes for some entity, for example, or for some person. So, but definitely not time series. Some of them are related to time series, but we are not interpreting them as time series. Yeah, you're welcome.
For your orchestration tool, do you use anything, or you build your own?
Yes, we're using Rancher, and Rancher 2 was released not far ago, and it's absolutely amazing.
Rancher?
Yeah.
Thank you.
Thank you, everybody. And we are hiring.
Thank you, Alex.